So let's try an example of finding mechanical advantage of a screw. So if I were to pinch and twist with my fingers this screw to screw it into wood, what would be the IMA? Well, two things might pop out at you at this question. The first one might be, well, Mr. Anderson, this thing isn't sharp, so it's not going to screw into wood. And that's true. We're just going to kind of use our imaginations for that one. But the second one is that, Mr. Anderson, my fingers aren't strong enough to put a screw into wood. That mechanical advantage clearly isn't strong enough, because if you ever try to twist a screw in with your fingers, it's not going to go in. It's not going to go into wood because you're splitting wood to get it in there. And both of these things are true. And we'll use our imagination for the first, and we'll address the second one at the end. And let's go ahead and just solve the problem. So let's start. We're trying to find the IMA. So IMA hasn't changed. Question is, what is IMA? Well, it's still DE divided by DR. Well, as we learned in our last video, that is just circumference divided by the pitch. Circumference on top and pitch on bottom. And we're trying to figure out what those two numbers are. So what numbers are going to go here and here? Okay, well, let's start with the circumference. We know the formula for circumference. I'm going to go ahead and write this shorthand. That is just 2 pi r, or in this case, it's pi times diameter. And that's the one we're going to use because we're given a diameter. And you might say, well, Mr. Anderson, it's 1/4 inch is the diameter because it said so in our previous example in our notes. It says that's the diameter. But that's the diameter of the threads. That's not where I'm putting my fingers. Let's go ahead and center this out. I'll be putting my fingers not down here, but I'll actually be wrapping it around. It's kind of a crude drawing of 2 fingers connected. I'm going to wrap around here, around this head. And this head, it says very clearly, is 7/16 of an inch. So if I were to draw that out, it's 7/16 of an inch from one end to the other. Let's get rid of that. So that's our diameter. So it's going to be pi, or in other words, 3.14 times 7/16, 7/16. And so to find the circumference, I will literally just type that into my calculator. So we'll say 3.14, ignore the fact that the numbers were already plugged in there. 3.14 times 7 divided by 16. And what do we get? We get 1.37375. So that's our circumference, 1.37375. And I'm not rounding this, and you could round it. It'll vary your answer a little bit, but it won't vary it enough most likely to make that big a difference. But I'm going to go ahead and keep it the same. 1.37375 on top. And with that, let's go ahead and find the pitch. Well, the formula for pitch is just 1 divided by the number of threads per inch. Well, we learned in our last video that the number of threads per inch is the second number. We don't need the first number. And so you might think, so the pitch is 20, right? But you'd be wrong. The pitch is not 20, because the pitch is the distance between 2 threads. This says there's 20 threads per inch. So that means if I counted out 20, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. If I measured out the distance between 20 threads, that would be 1 inch. But we don't want to know how far 1 inch is. We're not trying to find that out. We're trying to find the distance between 2 threads. Well, that's here. That's the pitch, that little tiny distance. And there's 20 of those. That means the pitch is just 1 divided by 20. It would take 20 pieces of 1/20 to equal 20, which would give us 1 inch. So if the thread count is 20 threads per inch, then the pitch would be just 1 divided by 20, or in other words, 0.05. We just plug that into our calculator. We put this number on top, and we divide that by 0.05 on bottom. And we get a pretty big IMA. We get 27.4, or 0.4, was it 75? Yes, 0.475. And you might say, well, Mr. Anderson, that's a pretty huge mechanical advantage. Maybe I could do it with my fingers. But the problem is, we are splitting wood with this screw. It is tearing wood open. With our fingers, if we are grabbing around this. If I'm grabbing around this, I'm grabbing it with my fingers, which isn't very strong. Or at least most people's fingers aren't that strong to split wood, to get anywhere close to the strength of splitting wood. Even if you increased the force of your fingers by almost 30, it still probably wouldn't be strong enough to split wood, which is why your fingers aren't strong enough. So we might need a little bit of extra leverage, which is what the next example will help us do in the next video.